lunch? Yes? Excellent. So someone came to me and said, please, next time talk slower. So I try very slowly. If I start to talk too fast, so I'm going to talk to you a little bit about Kotlin. How many of you are familiar with Kotlin? Okay, that's good. I love audiences that don't know Kotlin because then that means that I get to tell more people about Kotlin, right? So this is a good thing. Right, so what I'm going to do is give you a brief overview of what Kotlin is, and then we'll dive into the code. And I'll start with a little bit of a background of why we started with the Kotlin thing and where it is right now. So we started this in 2010 at JetBrains, and at the time we needed a language that was kind of concise, expressive, toolable, interoperable, and overall just pragmatic. If you are familiar with JetBrains, we create developer tools that are IDEs and server-side tools and .NET tools. So anything that is not .NET, which means all of our server-side tools and all of our IDEs, they're all created with Java. Okay? So Java is the main language. We create IDEs for Scala, for PHP, for Python, for any language under the sun, and yet we still like to code in Java. And we were looking for a language that allowed us to do some other things in principle, like cutting down on boilerplate code. Because you all write Java code and you know that it's not very concise. It's quite verbose. So we wanted alternatives. At the time, we looked at two main alternatives. One of them was Scala, the other one was Ceylon. For different reasons, they didn't work out. And that's when we decided to kind of embark on the adventure of writing our own language. And we did this with the idea of using it in our own tools. And we have been. To date, it's been used in more than 10 tools in JetBrains. And of course, we made it open source from day one and gladly welcomed other people to use the language. And it's been very well received. So what is Kotlin? It's a static language that targets the JVM. We then added support for JavaScript, and now we're also working on native. So you can target native applications as well. The current state was that it was released in February 2016, but we've been actually using it in production for at least 3 years. Some of the main core things of JetBrains are running on Kotlin. For example, if you've ever logged into your JetBrains account, if you've ever made a purchase on the JetBrains site, all of these things are running Kotlin code. It's exactly the same performance as Java code. It's 100% interoperable with Java code. You can use Java from Kotlin, Kotlin from Java. Right now we have 20 plus developers at JetBrains working on Kotlin's team. And the goal of Kotlin was initially to be a tool used by us. It remains like that from a revenue perspective. So we're not looking to monetize Kotlin by doing training or consulting, etc. Our revenue model continues to be our developer tool. So the faith is that, you know, if people use Kotlin, eventually they'll end up buying IntelliJ IDEA as well. Although everything that you can do in Kotlin and IntelliJ IDEA Ultimate, you can also do in the Community Edition. Okay? We've got 100 committers plus on Kotlin, so there's multiple external contributors. And as I mentioned, it's used in 10 products now at JetBrains. So our commitment is that. It's also used by external companies. Here are a few that we know: NBC News Digital, Expedia, Netflix, American Express, amongst others. Where can you use it? Anywhere. We made it for us, and we make developer tools. But given that it's compatible with Java 6 and it's got a small runtime, it's had tremendous success in the Android community. A lot of people are using Kotlin for Android development. But you can use it for any type of application, be it desktop, be it Android, be it client-side, even, and of course server-side web applications, etc. Since, and you'll see that it's very familiar to Java, C#, JavaScript, and Groovy, it's inspired by these and Scala to get a quick ramp-up time. It's not a complete paradigm shift from what you're used to. The idea was, we did this consciously. We wanted people that know Java to easily pick up Kotlin. Because we couldn't stop work for X amount of time and rewrite everything in Kotlin, or have people trained in Kotlin for years to then become proficient. We wanted a mix and match with what we have. And given that it's very interoperable, it really allows for gradual adoption. So it's not only about, let me just write my tests in Kotlin and my production code in Java or whatever. I can actually incorporate Kotlin into my code base. How can you use it? We've done it very open. You can use the command line, Maven, Gradle, Cobalt, which is a flavor of Gradle written in Kotlin, and IntelliJ IDEA. We even, Android Studio, we even make a plugin for Eclipse, which is open source also. You can download, and hopefully if you like it, you can contribute. And we also make a plugin for NetBeans. Obviously, I'm not going to tell you where we get the first features. You kind of guess which IDE is going to get the first features, but we try and keep those up in the other IDEs. Okay, with that, that's all of the slides for now, and let's switch over to some code. Now, normally when I create projects, I use Gradle. But for this demo, we're going to use Kotlin. It's just the IntelliJ build system. So I'm going to give it a name, and it comes with a small runtime, as I mentioned, and I'm going to hit finish. And now I've got my project running up, and I'm going to create a file, okay? So I'll create a file called Kotlin, and I'll name that file anything I want. It doesn't have to be named, it could be anything. And now I'm going to spit out a template, right? So, I'm going to run and I'm going to make. That's Kotlin. Got incremental compilation. First time takes a little while, after that's fine. So notice a couple of things. First and foremost, there is no class. Kotlin is an object-oriented language with functional constructs. But classes are optional. I mean, the majority of the code bases that we see in Kotlin are using still classes, but classes are optional. So that means that I can have the concept of top-level functions. So I don't need any static functions in static classes. I can just place functions anywhere I want. So if you're familiar with JavaScript, you already know what I mean, right? It also follows the convention of parse, the name of the argument, and then the type. This specific syntax, this signature, indicates that this is the entry point. So in Java, this would be the equivalent of public static void main. Okay? Print line is the equivalent, basically, of writing system out, which it expands. System out print line. It's the same thing. There is no import because certain library functions are implicitly imported. There's no package because you can have a default package, but I can create a package called demo, and that's so now it's part of the package demo. We follow the same conventions as Java. The only difference is that with Kotlin, you don't have to align the folder name with the actual package name. Okay? So now let's create a function. We'll create a function called hello that just prints hello. The same thing. Now notice that you start a function with a func keyword. There's no void. By default, functions that don't return a value are void. In Kotlin, we call void unit. If you go to unit, you see that unit is a little bit more than void. It's an object. And what is an object? An object in Kotlin is basically a singleton. It's a single object. Right? If you're familiar with JavaScript, it's the same thing, in essence. Right? So I have an object unit. I can query, I can say, is this returning an object, a unit? I can add parameters. So let's make this a parameter. Well, I have string interpolation. String interpolation. Right? I also don't have semicolons. You can put semicolons if you want, or you can not put them. They're optional. In fact, when you put them, IDEA says to you, why don't you just delete that? Okay? I can have parameters. So I can have message over here. And I just call it with print line. Hello. Some message. Okay? I can have multiple parameters, obviously. optional parameters. And I can make this optional. So now you see that's still valid, but I can pass a second one. This reduces overload. Imagine if this is a function of a member of a class, you just reduced a whole bunch of overloaded functions, because I can have optional parameters. Given I can have optional parameters, I can have multiple optional parameters. Now which one is which? Right? How do I know if second one's corresponding to message or if I want it to be optional parameter? Well, I can name parameters. And I can change the order. Okay? So, let's create another function, integer, that takes an integer and returns an int. And that is x plus 1. Okay? Everyone following that? Kotlin type inference is big. We like type inference. So if I write a message or a string, this is the full declaration. And then I can initialize it. But you see I never write that. I just initialize. The compiler figures out what the type is. Much the same way, when I have a function that returns just a single value, it's just an expression, I can get rid of a whole lot of code. And I can just do x plus 1. Okay? Now let's create a class, because there are classes in Kotlin. We'll create a class called customer. And there's my customer class. I don't need anything else. Now I'm going to create a class, customer, with two properties, an ID and a name. The ID is read-only, the name is read-write. And I'm going to create a constructor for it as well, so that every time I initialize it, I have to pass in those values. Well, ID int, var, name, string. There's my class. Right? Let's go ahead and create an instance. One. And let's go ahead and print it out. Okay, see what that has. I get a horrible little pointer over here, which is an X. Let's fix that. Is that better? That's a toString now. So, let's write that same class in Java. Here we go. So, private int ID, private string name, and now let's go and create a getter and a set. Actually, this one doesn't need a setup, okay? And let's create a constructor that takes the two parameters, and let's create a getter and a setter for this, and let's go ahead and create an equals. And yes, we want to have all the properties. And let's go ahead and create some overrides and a method. Come on. Override method. We're going to get long string. And there you go. I think that's all I needed. Yes. So now let's close this. Let's open this. Edit the tab. Split vertical. Go back to customer. You tell me which one you like better. Okay? Now you're going to say, oh, big deal. You got IntelliJ to generate that for you. Of course. But how do I know that that's going to remain that way? When I add a new property, I've got to update everything. How do I know that the code in there is actually the stuff that IntelliJ generated by default, or it's been tweaked? Right? All of this is boilerplate code that is not necessary, that you can cut down with Kotlin. Okay? So that's a data class. And look at the interoperability. Let's go over here and let's create a customer in Java. Customer in Java. Okay? And it takes a 2 and something. Now, if I do customer in Java, I can do a getID. But as soon as I do getID, IntelliJ says to me, no, use ID. Because we don't have the concept of getters and setters in Kotlin. So So in Kotlin, you access it through a property, right? And if I say name is something, I could of course say customer in Java set name something, but you see that it's giving me that hint, right? It's saying use property access as syntax instead. So I will. Now let's go to Java. And let's create an entry point here. And we'll say customer equals customer, new customer. One, blah. Now, notice that IntelliJ is kind enough to give me the property name parameters because we don't have that in Java. Customer get name. That's how I would use it in Java, right? So it's 100% interoperable, bytecode compatible, electrical. Okay. So we've seen classes, we've seen functions, but no language nowadays could call itself a language if it doesn't have functional constructs. And functional constructs is when you treat functions as first-class systems, right? So what can Kotlin do with functions? Well, first of all, here's a problem. It's not a problem, but this is how it's designed. Let's say I take a class person, and now I say that customer is a person, and it says you can't, because by default in Kotlin, types are final. You have to mark them as open. So now I've marked that as open. I can now inherit from this person. I can now add functionality. But sometimes I don't want to do that. But anyway, let's use this person and let's do something with it. Okay, so we're going to have a person here, and we're going to say if person is customer, then person name equals something. What's missing? A cast. Right? The compiler is smart enough to figure out that I've already checked that that is a person, that it's not going to vary, and I can now just auto-cast it. It's the little things, right? But anyway, let's go to this customer. Or let's say that I have a customer or any class and I want to extend it with some functionality. Well, I could inherit from it, but we all know inheritance isn't great. So let's create what we call extensions. Here's a function that takes the string and prints line hello. So now watch this. While my string equals something, right? My string hello. I've just extended the function. I've just extended string with a new function called hello. If you're familiar with C#, this is similar to extension methods, except it's much more subtle and concise in how you write it. Let's do something like string should equal. And we'll say value, string, and this is going to say if the value is the same. So I could say is me should equal is me. That's nice. But I can make it nicer. That's much nicer, yeah? You can do that. Any extension function or any member function that takes a single parameter can be called in infix notation, right? And that's one of the things we wanted to do with Kotlin, and I'll show you some examples, in that we wanted to create a language that's easily allowing you to create expressive, concise code. And you can even create little DSLs with it. Okay. Let's do some more. Let's go back to functional. Kotlin, functional. So, let's create a list of numbers. And let's filter out all the numbers that are less than 100. Right? Numbers, filter, if less than 100. And then take those and map those to multiply it by 10, and then on those, let's print them out. Okay? All of these are higher order functions that are part of the standard library. What's a higher order function? A higher order function is a function that takes a function or is under function. So let's create one. Higher order, x integer, y integer, function. Now I'm going to have a function that takes an integer and returns an integer. And this function itself is going to return an integer. So now we're going to do return, take that function with the parameters passed in, and return it. Right? Now I have a function over here that matches that signature. If we go to main, you see that I have add. Yeah? So I could say higher order, 1, 2, add. Pass in a function by name using colon. I don't need to do this. I can also pass in lambda expressions. X, y, x plus y. Right? With lambda expressions, with any function that takes a function, if the last parameter is a function, I can change the way I call that function by excluding it from the brackets. So I could do this. Which means I can also do something like this, multi-line. And you're saying, why would you want to do that? Are you crazy? And I say, no, watch. Using object closable, block, try, block, finally, object close. I've just extended my language in a way by creating a new construct that takes any object that's closable, does something with it, and makes sure that it gets closed. That's exactly the using statement in C#. Kind of similar to try with resources in Java. Now this doesn't look like a function anymore. It feels kind of like part of the language. And in fact, coroutines, which we implemented in Kotlin 1.1, is using, you can do asynchronous programming using async await, but they're not keywords. They're not part of the language. They're just functions. But they feel like part of the language. Okay? What you see here with it is a convention, in that if I have a higher order function over here that takes a single parameter, let's say single, then what I can do is reference that parameter with just a single, or with an it. I don't have to be explicit in the lambda declaration. So now I could do higher order higher order single 1, and then x is x plus 1, or I could just do it plus 1. Okay? That's the same convention as in group. So what we're basically doing is just adding a series of things to the language to make the code that you write much more concise, but at the same time still expressive. Now, one other thing that Kotlin has is that by default types aren't null. So if I do val string, by the way, val means if I write message 1 equals something, I can't ever do message 1 equals something else, because the type property is read only. If I want to do it read write, I do it like that. We underline it because while we don't enforce immutability, it is recommended. Anyway, I have this message 1. Now the complete declaration of this would be string, and then I could initialize it. Or I could initialize it later, it's not a problem. Now, if I come here and say null, you see that it says you're not allowed to. Value cannot be null. Because by default, nullable types aren't there in Kotlin. If I want to create a nullable type, I add a question mark. Right? Now it's nullable. So now I can do if message is not null, then message length, whatever, print line length. Now this is, notice that it's casted. What? It's smart casted to a string, because there's a difference between a string, a nullable string, and a string. So this, you normally wouldn't do in Kotlin, because in Kotlin you actually don't work as much with null. And then you don't have all those null state strings. But since we need to interoperate with Java, we tend to end up in a situation where we have to continuously do this, right? So what we do here is we make this even a little bit shorter for you to write. So I can say message 1, actually let's go print line. Print line, message 1, which is the always operator. So it says if this is not null, then invoke length. Okay? So, what else do we have? Let's create another class. How many of you know Express.js? Or Synapse? Or any of these other web frameworks? I'm going to create a class called request that takes a property query and content type, or I don't know, an accept header, accept type, string. And I'm going to create a class called response that takes a status code, which is of type int. I'm going to set that, and the status text of type string. Now I'm going to create a class called root handler that takes a root handler that takes a request and a response. Okay? Now I'm going to create a function called get that takes a path and it's going to take a function. But that function is not going to be a typical function. It's going to be an extension function, which we already know what it is. It's going to be an extension function on root handler. And it's going to return that function. Okay? Now I could do something like this, get index, and then handle that request response. Imagine I'm doing like some HTTP or some REST API. Now, if this were a normal Lambda, like if this was something like this, request response, here I would have to do request, response, and then access request dot accept type dot query. Okay? But I'm not going to do that because I don't want to have to write all of this lambdas type parameters here. So I'm going to leave that the way it was and watch now. Magically have access to request. Why do I magically have access to request? It's not magic. This lambda is an extension function to the class root handler. Consequently, it has access to any of the properties of that root handler. Okay? So I could do request, if request is query equals not null, then response status code equals 200, response status text equals okay, for instance. That's nice. But I want to make it a little bit nicer. I want to do something like response status code equals 200, response, status text equals okay. That's much nicer. It gives me like a nice DSL feel to it, right? I can't do that. But let me show you something. Class manager. Right? I'm going to create a class manager, which we've seen. And what I want to do now is go to class manager. I'm going to create an instance of manager. And I'm going to want to invoke manager. I'm going to say, do something with instance. I want to invoke a function, functionality, by invoking the object. JetBrains tells me how to do that. It says create a member function called invoke and declare it as an operator. Call that a string. And now I can invoke that. And you're thinking, why are you doing this? Wait, I want to get to that. So to get to that, what I'm going to do is I'm going to rename this to status result, right? And then here I'm going to create a class called response. Response that takes an actual status result. Okay? And now if I come back here, this no longer works. So let's get rid of it. And let's uncomment this. And IntelliJ says, oh, do you want to create a member function called invoke? And I say yes. And this is going to be status result. And the type is going to be status result extension. Okay? And now magically, my DSL is there. It's these couple of things that we add to the language that enable you to write these DSLs. This thing here, many of the things that I've shown you in Kotlin are not unique to Kotlin. Many other languages have it. This construct is, and we call it a lambda with receiver. Okay? So hopefully that gives you a little bit of a feel of what Kotlin is and the syntax and what you can do with it. We actually, based on our estimates and based on what people are using, telling us, you can pretty much cut down your code base by around 40%. Okay? And in fact, when you want to get started with Kotlin, there's even a function inside IntelliJ in the Community Free Edition 2, which you say convert Java file to Kotlin file. So it can get you started, and then you can kind of make it a little bit more idiomatic Kotlin. There is no convert Kotlin to Java because once you go Kotlin, you don't go back. So, Anko is an example of, how many of you do Android development? Anko is an example of a library we wrote, which is basically creating a DSL that allows you to create views without having to use XML. But everything that you see here is what I've shown you. That's how you create with what we saw today. Android extensions is because the compiler has a plugin. It has a plugin model. The compiler has a plugin model. We can do some awesome things. So here, for instance, when you're working with Android, you always have to do find view a string of a component and then cast it to an actual type of component. Okay? The problem is that that becomes tedious. So with the Android extensions, which are available for both IntelliJ IDEA and Android Studio, it basically gives you a statically typed control with the type of the actual control. And we do this using plugin technology. And that same plugin technology is going to be used for others. So for instance, if you work with Spring Framework, one of the things you might know is that a lot of things have to use dependency injection and have to be able to be open, right? You should be able to inherit from them, etc. So you know that in Kotlin you have to put open. Now a lot of Spring developers were complaining and they were like, oh, we don't like to decorate. So we're going to create a plugin, a compiler plugin that allows you to decorate certain classes as open without you having to explicitly do it each time. Spring Boot, in fact, supports already Kotlin, right? So if I go to Chrome and I say start.spring.io, you see that here, switch to full. How many of you use Spring? 5. Switch to full version, and the language already has Kotlin. Okay. Cobalt is a flavor of Kotlin, is a flavor of Gradle written in Kotlin. It uses Kotlin. Of course, this project was initiated before Gradle announced that you can now write your Gradle scripts using Kotlin. So in addition to Java, you can also use Kotlin. Okay? Any Gradle people here? I don't mean people from the company, I mean like people who use it. So, if you want to learn more, which I really hope you do, next step, you go to kotlinlang.org, try kotlinlang.org, which gives you this wonderful little thing here. It's basically a IDE in the browser, so to speak, which allows you to kind of try Kotlin and go through a series of exercises using koans. Okay? It tells you how to complete each of these. If you don't like to do it in the IDE, online, then you can download those koans. They're available on GitHub. All of this information that I'll show you now is, if you just go to kotlin9.org, you'll be able to see it. And you can do those koans in your IDE. There's already books out available for Kotlin. If you're doing Android development, there's this one. Kotlin in Action is already complete. It's being published now. But you can already buy it manning the early access program, and it's by Dimitri and Svetlana, who are my colleagues at JetBrains. I did a Kotlin course on Safari online or O'Reilly, about 9 hours of video courses on Kotlin. There's also courses available on Pluralsight and I think Demi has just published a course. So there's already many courses on Kotlin online. We have a very, very active community. We have over or close to 5,000 people on Slack. And there are channels for all different topics, so if you want to get on board, go there, they'll help you out. And of course we have a Twitter account. So to summarize, what we tried to do here was create a pragmatic language. Right? We didn't want to reinvent anything. We didn't want to have a massive shift from the mindset of what we're used to. We wanted to leverage the knowledge of our developers and developers that are out there to use a language that is more concise, functional, and expressive. And toolable, which is a big thing for us. With an easy learning curve. Given that it's interoperable, and you've seen it provides very low risk adoption in the sense that you don't have to wait for thousands of frameworks to appear because everything works. Vertex, if you work with Vertex, has already adapters for Kotlin. Okay? And of course this is very subjective, but it's enjoyable, and I can promise you that you will enjoy it. And very importantly to mention, the Kotlin is here to stay. So we are using it for our own tool, which is our bread and butter, which is our revenue generator. And we're committed to it, and we're showing that commitment in the code that we're writing in our tools that we're studying, and having Kotlin be that code. Okay? And I'll finish off with this tweet from Brett Midler. He said, researched Kotlin last night and then spent the morning looking at mountains of boilerplate Java in Android Studio. I see why they did it. And yes, that's pretty much the reason why we did it. Thank you. I think we have time for a couple of questions, and then if not, we can go to coffee. Yes?
I'd like to ask a small question. How big is the runtime library?
It's under 1 megabyte.
Okay, thank you.
Another 1 minute.
As a JVM language, we all know Scala is a very good language. What is the main difference between Kotlin and Scala?
Okay.
What is the disadvantage except the learning curve?
Okay. So the question is, what is the difference between Kotlin and Scala? And that's a very good question, because if nobody would ask it, I would ask it myself. Generally, here's the answer. If you are happy with Scala, you probably do not need Kotlin. Okay? What is the main difference? We restrict the language. So if you've been working with Scala, or know people that work with Scala, or even companies that talk about it, many companies have what they have like a style guide of what you can and cannot do in Scala. Because in Scala you can do everything. In Kotlin you cannot. The idea with Kotlin is that we built that style guide into the language. We've restricted it on purpose because we want to avoid leading to complexity. Okay? So you cannot override and you cannot define any symbol as an operator, for instance, in Kotlin. There's certain conventions, and that's it. You can only follow those conventions in operator overload. It's obviously it's much more, well, it's more performant than Scala, right? It's more toolable than Scala. It's easier toolable than Scala. And I can guarantee you that because we make tools for Scala. right? We have, to give you a little bit of a perspective, we have about, I think, 35 people on the IntelliJ team, right? And we have about 12 people just dedicated to the Scala plugin. And I think on the Kotlin side, we probably have about 2 or 3 people. Scala is not an easy language to tool. So obviously we can provide you with much better tooling when it comes to Kotlin. That's not to say that we're going to, not continue with providing tooling for Scala, because we have many Scala users. Okay? Another question. Yeah, 1 second. Get the microphone.
Okay, I think Scala is simple and powerful. I'm studying Golang. Do you know Golang?
Yes.
What's the difference of Kotlin and Golang?
Well, you think the Scala is simple and powerful, did you say? Yeah.
Yes.
So then, you don't need Kotlin. Sit down and give the microphone to him. You just got a free t-shirt for nothing, my friend. No, I'm joking. Let me answer your question. Yes, if you have, as I said, honestly, if you are happy with Scala, you will see no benefit in Kotlin. It's that simple. Let me just answer. In regard to Go, I mean, this is a completely different thing. Go is a very small language that is not based on the JVM or anything like that. What will happen when Kotlin hits the native? I don't know. That time will tell. I can't answer that right now. Okay, your question.
大家好，抱歉我要说中文了。我是科特林中文站的本地化主要的本地化成员之一。我也希望大家能够支持我们来翻译这个科特林，也包括刚才那个关于 Scalar 的那个问题，实际上在那个 FAQ 里都已经有了而且 FAQ 是我翻译的。我觉得科特林是一个非常棒的语言，然后我希望大家也能够更好的支持和推广他们，也希望那个官方能跟我们能有更多的互动。
Yes, absolutely. Should be no. Oh. Awesome. Can we give him 12 t-shirts? Thank you very much. Awesome. Okay, so I'm still well, yes.
Do you have some killer IDPs on will you make it open source?
Do we have some what IDPs?
Killer IDPs.
Killer application. What is a killer application? Like awesome applications. Yes, well there's a lot of applications. The problem is that if you go to our website, you'll see a list of people that have said they've written their applications in Kotlin. Well, but not everyone shares that information with us. What we found out recently, for instance, is that Pinterest, you know Pinterest? That's written in Kotlin. Parts of Uber are written in Kotlin. There's American Express applications are written in Kotlin. NBC News Digital are written in Kotlin. A lot of Android applications are written in Kotlin. Outside of Kotlin, there's also many applications. In fact, there is one application that was recently announced, which is a financial application that they've made open source. They're going to make open source, which is a conglomeration of 70 financial institutions working together. They've written it in Kotlin as well. Oh, and also, of course, our applications, which are killer applications.
Hello, my question is how Kotlin deal with generate functions. I know Java's generate has many problems. I wonder how Kotlin deal with it.
Yes. So we have support for generics. We have whole site variants and declaration site variants. So you actually declare whether a generic is covariant or contravariant on the declaration. And then there are scenarios where you can use it in a code site. Consequently, what that means is that it is much cleaner and easier when you're writing code, because you don't have to write all of those symbols and syntax that you use for Java. I think there was a question. No, but there was one person before.
你好，我是 OK， 是这样，我想问一下，就是这个科特林能不能和现在的 Java 代码兼容？因为我们现在的已经上线的项目里面的 Java 代码实在太多，如果不兼容的话，我们对一些第三方库的引用，那将是一场非常灾难性的事情。
Yes, it's completely interoperable with Java. I mean, we were seeing it in this demo. You can call Java from Kotlin and Kotlin from Java. Can we just take that gentleman's question, because he did have his hand up, yes. And then that will be the final one. And what's that one else?
I want to know when Kotlin will grow Java 6 or for Java 6 runtime, right? Java 6.
Yes.
Java 6. When will Kotlin go to Java 6?
Oh, we have no imminent plans to drop Java 6. Java 6 support is going to be around for a very long time.
Very long time.
Yes.
And then when will Kotlin 1.1 be released?
Sometime in the new year, which is very, very open. Okay. The more like I don't mind. We could spend an hour here answering questions. Problem is that means less time for you to have coffee, and now you've only got 12 minutes to have coffee. So whoever wants to leave to have coffee, more than welcome. If anyone wants to stay, I can still take questions here. Okay? Thank you.